I've been round and round on what to do about the two hardened shafts that are in this machine that are worn. This one is the main shaft for the transmission gear, and then this one is from an idler pulley. Both shafts are pretty severely worn in different ways, and it's been proposed pretty frequently that one resolution or one solution is to get them ground and then industrial hard chromed and then ground again to the right size. However, the several places that I've contacted that can do the grinding and the hard chroming and then the grinding again have come back with estimates that are way over my budget. So I've decided to try making them new. I'm going to turn them on my friend Dick Kite's lathe and have them hardened and then ground. One of the challenges in making them myself is getting the right steel. So these are made out of 52-100 steel, which is basically bearing steel. I often buy pieces of metal from a place called Metal Supermarket up in Fort Worth, and they wanted $540 for a 12-inch piece of 52-100 steel. After a lot of searching, I found a place called Sullivan Steel up in New Jersey, and they had a 15-inch piece that they sold me for $150, shipping included. And it came with a certificate of authenticity, or whatever you want to call it. I guess it's a certificate of certified metallurgical content. So I'm going to go offline and come up with a kind of a manufacturing sequence to optimize material usage so I don't waste any more than I have to of that rather expensive steel. Here I am again at my friend Dick Kite's place of Ryan Machine LLC. So I've got the bar stock for those shafts set up for center drilling. I ended up switching chucks because the other one was flexing a little bit. So here we are after about a dozen passes. I'm taking about 20 thousandths off the diameter with each pass. And this 52-100 steel is creating quite a bird's nest of chips. So I'm sure someone will chime in and tell me what I'm doing wrong. So this shaft is roughed out. I've got it turned about 20 thousandths oversized in diameter. Alright, I've got this cut off to size on the horizontal bandsaw over there. The grease port on the original shaft was only exiting below the top needle bearing. I'm going to reposition it so that it's coming out between the two needle bearings. I've drilled this inlet port deep enough to accommodate the new location. Now I'm working on the second part. This is the shaft for the idler sprocket, and it's got the hole through the middle of it that we'll have to bore. Alright, I've got a line laid out for the second shoulder on this second part. Let's get going. Okay, we're gearing up to drill out the center of this second shaft, the idler sprocket. We also need to face off the top of that boss. Well, I'm halfway through the drilling operation. I've done about halfway from the other side. I'm expecting it to break through any minute now. There, it finally broke through right there. Now that I have the dead center out, I'll gradually increase the diameter of drill bits until I can start using a boring bar. This will be the biggest drill bit I go to before switching to a boring bar. This should be breaking through the halfway point pretty soon. There it went. There's the halfway point. So I'm on the home stretch here. I'm using an end mill to finish out the boring. We're on the final couple passes on the other side. Okay, with this idler sprocket shaft roughed out and complete, the only thing that remains before I get it hardened and ground is drill a set screw alignment hole. So I'm just going to use my vise and align it from the old part. And so that should be where it needs to be drilled. Okay, well, I just picked up my shafts from Southwest Metal Treating. So they hardened them to an RC 67. I was shooting for 66, so I'm glad I got a 67. So the next stop is to drop these off at Fort Worth Centerless, and we'll get them ground to size. Well, I got the shafts back from Fort Worth Centerless grinding, and they did a really nice job on the finish and the fit. So they ground the shafts to be just a perfect fit for the bearings. So they're like just 1 or 2 thousandths over nominal, and the bearings fit much better than what they were fitting on the original shafts. So I've got the new needle bearings pressed into these sprockets. And you may have heard me bragging about how Fort Worth Centerless ground these so nicely to fit the bearings. We'll leave it to Tim the Toolman of OWWM to point out that once the needle bearings are pressed into the sprockets, that the bearings will probably become a lot tighter. And he was right. Now, surprisingly, the idler sprocket is okay. I don't have any problem with it. However, this main shaft for the transmission, I cannot even start to get the sprocket onto that shaft, so I'm going to have to send this back to Fort Worth Centerless and have them do a little more work on it to get it to fit. After the second trip to Fort Worth Centerless, the main shaft fit into the sprocket just fine. Next up are the riser shafts.